Welcome back. Our next panel will focus on the topic of research, the building blocks of innovation, and the contribution of the MIT Portugal program to the national competitiveness and the socio-economic development of Portugal. On stage we have Paulo Ferrão, Professor of Técnico Lisboa, member of the MPP Governing Committee and MIT Portugal former director, João Faria, Innovation Manager at DST, Eduardo Pereira, Professor at the University of UMinho, Ana Barros, Head of the Human-Centered Design at Fraunhofer, Portugal. They represent the entities involved in some of the MIT Portugal program's past and ongoing research projects. Moderating the panel is Alexandra Moutinho, MPP Lead Faculty of Earth Systems, Oceans to Near Space.
Okay, so good morning to you all. Someone already did my presentations, so I welcome you all to the stage here for this very important MIT Portugal Program Annual Conference. Thank you all for attending. We will have this session here regarding research, so the building blocks of innovation. We will have here the presentation of 4 big flagship projects that show the importance and all the efforts that the program has been doing to bring technological advances here in Portugal with collaboration with the MIT team. So, Paul, thank you very much. The floor is yours.
Thank you very much. So I hope my slides will show up, but in the beginning I would just like to let you know that I was interested and intrigued when I was invited to present the Green Island. And indeed, the Green Island was eventually the first flagship project from the MIT Portugal program. And what I'm going to show you are real archaeological slides. So I went into my files, and the only slide that I built was the last one. So all the others are real slides from the good old times. Now let me ask you a question first. Imagine. Let me challenge you to imagine. Imagine the present. So could you imagine a present where you want to have an Europe which is carbon neutral, no fossil fuels, that you have an Europe which is in war with a lack of gas and want to be autonomous? Well, even today it's not easy to imagine, but that's what we have imagined 15 years ago, 2007, when the MIT Portugal program launched the Green Islands project. This was really a project that was intended to have the Azores, an island, as an experiment to demonstrate that it is possible to give steps with politicians, with companies, to reach carbon neutrality. It was a fantastic pathway. But by the time we did, well, we can only do that with students, with research, speaking with the companies, speaking with the governments, and that was the history of the Green Islands that I'm going to show you in this very archaeological presentation. So the Green Islands was really intended to design these sustainable energy systems. By the way, I want to tell you that when the MIT Portugal was born, so one of the 4 areas that was designed was sustainable energy systems. So I'm so proud of that today. It's now self-explanatory. It was not 15 years ago, so it was brand new. And indeed, there was this idea that it would need to be, well, very, very multidisciplinary, going against the odds, which is eventually the oil companies, I don't know. But indeed, the Green Island project, I need to confess you, started in the Azores, in a lunch, where I was, because by the time I was the MIT Portugal director, and then the CEO of Galp and the president of the regional government of the Azores. And then it was the idea, why don't we make a flagship to make the Azores a great example into the future? And then we started by doing, how do we do this? First, we need to get data. So we spoke a lot about data. So we need to get data from the Azores to make scenarios. But then we started a full-fledged program with PhD students on developing energy systems modeling. And this was the major contribution, I think, still today we have from the program. And then, of course, we started to develop some demonstration projects. By the time, I would like to tell you that we have a wonderful experiment, 9 different islands. You can pick an island with maybe 500 people, and an island with maybe 200 and something thousand people. Very different. São Miguel, the main island. the biggest island, the main will be very unpolitical to say, the biggest island, had a very special reality because it had, even by the time, geothermal energy, so in excess. So can you imagine? There was geothermal energy in excess. And then all the full renewable energy in electricity in Azores, in average, was 29%. And then, of course, we start to make our models. And when something that is very important, and the MIT Portugal started to make that very clear, we start energy modeling by the end. The energy serves a purpose. So you need to understand which is the purpose that the energy serves. So it can be to agriculture, industry, domestic services, and commerce, transports. And then you go backwards. How can I better fulfill these energy needs with the different energy that I have? So, and this is a proper energy systems analysis. And then, of course, this was totally dominated by oil. So 87% of the primary energy in the Azores was oil, very expensive oil. So this was good in a certain way because the renewable energy became relatively cheap compared to the oil by that time. So, well, you need to think we were 15 years ago, there were not this peak of energy, renewable energy as it is now. And 7% of renewable energy, so in primary energy. So 47% of renewables on electricity, by the time, represented 7% on primary energy. And then we started to develop different scenarios. And what was very important, so we developed the different scenarios with EDA, so the electricity of the Azores. So that was fantastic, because we developed that with them, with the MIT team, with the different students that we had in Portugal. And all of them could develop very, very different scenarios. And I think this is the most important diagram I want to show you. So what is the problem? What is the mindset? The mindset is that, well, when you want energy in that second. But then when you plan energy, you want to have the energy stored for that precise second. So that's why you use oil. It's very easy. So you have an engine, you want more energy, you run the engine faster. And that's easy. So it is going from the energy, the engine, to the use. If you want to have renewables, that's not so easy because you do not control the wind, you do not control the sun. So you need to model at each second, and you need to develop storage. So that's why all the models need to consider time, extremely high time resolution. And then, what you need to do is to look at for example, this is the São Miguel demand peak, demand energy. So by this, what you see is that, for example, we had renewables energy in excess with the geothermal during certain periods, for example, by night. And what you did, you need to store this energy, to make the storage of this energy, and then to provide it when you have need for it. And then you need to start thinking, well, how do I storage? And then all the plethora of PhD theses start to bloom by the time. Let me go a little bit through them. Many, many dozens of theses. I will just show the ones I had in my archaeological files. So André Pina started to do energy systems modeling. I would like to let you know that nowadays he was one of the head energy planners of EDP. So, and now he is one of the head people that studies hydrogen in EDP. EDP is one of the main energy companies in Portugal. And by the way, I think the 5th biggest in the world in renewable energies. So, Antonio Santos started to look at the electric grids. So this idea that the electric grids need to be intelligent. Gonçalo Cardoso started to be looking at modeling distribution of energy in buildings. So now we lost him, so he is now in Berkeley. So, but okay, but that's something very important. MIT Portugal is a network, and any time, if we need, and we should, we need to organize it to call it from all over the world. This is something very rich, something very important that we should try to think about. Maria Kapsalaki, design of carbon neutral buildings. Christoph, this was the beginning. Now we have the super champion of the world in energy in buildings working with us, but that was a pathway of 15 years. Thank you, Christoph, for being the champion of today. We had other champions in the past. Cristina is now a professor in a university in Portugal. She worked in the economic of EV, electric vehicles, 2007. That's the point I want to make to you. So we were looking into the tools that now seems obvious, but 15 years ahead, and this is paying. So now we have the professionals that are changing Portugal and beyond. And for example, Joanna looked at smart meters. This was a project, for example, with Galp, installing smart meters in the house of the people, looking at the social aspect. How do people use energy? How can we provide feedback to the people so that they change their behavior? This was the multidisciplinary aspect that MIT has always, the MIT Portugal always had. So bringing together the social, the engineering, the economics, the architects. So if you look at the plethora of the sustainable energy systems, for example, which is the one I know best, you have all these people from sociology, economists, architects, engineers, and so forth. So that is very, very important. And of course, we looked into this situation, never happened. So what's to build? We developed two scenarios. So one was to build an artificial lagoon in the top of a mountain in the Azores to pump the seawater, because then when you have excess of renewable energy, for example, from geothermal in São Miguel, you could pump the water into the dam, into the lagoon, and then by day, when you need it, you turbine it. And then we were asked to develop another project, which was in Lagoa das Furnas, to design this with a lagoon in the top, but it never happened as well. So sometimes the dream, the ambition goes further away than the reality, but it will come the time. It will come the time. I'm sure you will see in 15 years some lagoons in the Azores to regulate the energy system. So, and then, of course, the energy system was totally different when we finished this. So with different elements, with smarter uses in the houses, with smarter uses in the electric vehicles, with the new storage systems. And then, if we have done this, we could have, for example, in São Miguel, 84% of renewable energy by the time. Well, São Miguel was a story. Something was implemented, something was not implemented. But my final slide, the ugliest one, so the one I prepared on specifically to you today, because I wanted just to get you two messages, nothing else. But still, the government was engaged. They created a directorship for energy because of MIT Portugal, working very close to us. The EDA was very much engaged. So, and nowadays, we have raised the Azores renewable energy penetration from 29 to 39%, different projects. We did a project in Corvo with 400 people, where we have implemented solar panels, wind, and then to try to get it more and more renewable. And there was this project in Graciosa, where they have a huge battery to balance the wind. So things have happened, we have moved, but above all, this is about people. So we have now the people that are changing the world today because they have this vision 15 years ago. Thank you very much, go on. You are in the right position, MIT Portugal, and I think you are looking into the future. Thank you.
Thank you so much, Paulo, for this inspiring talk. Now we have João Faria from Dstelecom to present us the flagship project, AEROS? Sorry.
No problem. So, well, good morning, everyone. First, a short disclaimer. Perhaps if you are paying attention to the prospect, today should be your elder from the project. However, he had a last-minute urgency, and he couldn't come. I'm here to substitute him, but I'm not going to talk that much in detail about AEROS. Instead, I will present you a short story how innovation, academia, and industry all come together in the evolution of a company. So I'm coming from Dstelecom. Dstelecom is a company from the ST Group. And this company, the ST Group, started in the 40s with a simple business. It was a quarry, and it was harvesting stone. And now, many, many years after, we are more than 2,000 workers, more than 50 companies distributed around 15 countries, and we have 6 main areas of investment, which are engineering, environment, renewable energies, telecommunications, and real estate. Of course, I'm coming from the telecommunications sector. This is where I can tell you a little bit more in detail. But before that, I would like to tell you a little bit about the culture of the company. So DST Group is the company in the north of Portugal which has the biggest private investment in culture. We are funding mainly literature projects. We have our own literature prize, and we also have a lot of investment in innovation, either through projects or internally through our dissemination of innovation. And in terms of culture, we have a campus which is highly filled with pieces of art. So we have murals, we have statues, and inside of our offices, I can tell you there's not a single wall which doesn't have a painting. And this is quite different from industry, mainly in Portugal and in the north and in the construction sector. That's where we all started. And we have mainly 4 pillars regarding the innovation. So we have R&D, we have teams developing new projects. These projects can be either funded externally or with our private investment. Then we have the innovation here. We put all our efforts and what we do internally to foster innovation, to make it with all of the workers in the company. So every one of us has to dedicate a minimum of 5% of our time weekly to promote innovation projects. Then we have our cooperation with the academy. We have many programs, exchange programs, to foster innovation and mainly to bring this knowledge out of the university to the industry world. And then we have an entrepreneurship pillar which focus on leveraging businesses and new businesses ideas. And of course, we are talking about projects. We are now in 4 areas of projects: space and sea, energy, IoT, and circular economy. And we have 2 projects in cooperation with the MIT Portugal program, which is the K2D and AEROS. Regarding K2D, I won't say much about it because Eduardo will present it after me. But regarding AEROS, I can tell we are developing a platform for a nano-satellite, which will monitor the seacoast of Portugal. And in this project, we have mainly 2 groups of payloads. We have an image payload and also a communications payload. In the image, we are talking about a hyperspectral camera and an RGB camera. And regarding communications, we are planning to establish communications with 2 types of sensors, one for Argos, which tracks mammals. And now we are also developing a LoRa protocol communication, which will be helpful in the future because LoRa is an open protocol. And we expect that this will be highly used for the academy due to the low costs and easiness of implementation. And of course, as I mentioned, we have other projects in the IoT sector, energy, mostly about photovoltaic energy and storing energy capabilities, also blockchain technology for smart contracts between different houses or buildings. So as I mentioned, in the AEROS, we are developing a nano-satellite, and this is the consortium. We are with Edisoft, SEIA, Spinworks, University of Minho and Porto, Algarve, Técnico in Lisbon, Collab, Atlantic, and of course, MIT. So what I wanted to tell you is what is the main benefits of this cooperation with MIT and academia in general. First of all is the contribution to technological development. So a few years ago, like 3 years ago, we were not even thinking about satellites or submarine cables. And alone, we wouldn't be able to pursue these topics, these areas. But with this cooperation with academia, we have the grounds to actually start having some developments in this area. Then it accelerates the innovative capacity, because when we are working in this kind of projects and our teams have the interaction with R&D and professors and investigators from the university, we also develop our internal knowledge, and the professional development of HRs because now we are more than 4 PhD students in the company, and 3 years ago we were 0. So this is also helping us to fast forward our own evolution. And of course, it empowers our relationship with other companies, with other universities, so we can prepare better for the challenges of the future. And that's pretty much it. Thank you very much.
João, thank you so much for the presentation and for accepting this last-minute invitation. So now we will have Eduardo Pereira. So he will be presenting K2D, the knowledge and data from the Deep to Space project. Thank you.
Hello, everyone. It's a great pleasure to be here today with you. I will try to represent this very enthusiastic team from K2D project. I'm the scientific PI of this project. We have a vast and multidisciplinary team, including João from the Dstelecom. They are the promoters of the project. Also, University of UMinho. There's also a student, Marcos, in the room. Ines Tech, colleagues from MIT, Doug also in the room. Air Center, the University of Açores, and also the University of Algarve and Sintal. Also, Alcatel Submarine Networks, they are our partner, and they have been in contact with us. We have been exchanging some ideas. So what's the thing about K2D, knowledge and data from the deep to space? Basically, the challenge is to try to address the main problems that we have, that we face, to learn more about our planet. We know that we have, well, the essence of this project is that we know we have a huge number of underwater cables, submarine cables. They are primarily used to transport information between different continents. The network is huge and is growing very fast. And the particularity about these cables is that they are laying down in the bottom of the ocean. They are in areas that are remote, very inaccessible in general terms, and they are constituted by 2 different types of elements, the cable itself and the repeaters that are placed every 50 to 70 kilometers in order to improve the quality of the signal and make possible the transport of the information. Of course, these repeaters, they are links, possible links to the cable, and there is a big opportunity to use these cables as a system of monitoring for the oceans. This is not completely new. The smart cable concept is maybe 10, 15 years old. But in our case, we are trying to increase this vision to a second version where we want to cooperate this system, this infrastructure, together with autonomous vehicles, with underwater robots. And for that, we have to look in particular to the repeater and how we can connect to this element. On the lower side, we can see a simulation. Basically, this is the submarine cable structure that is anticipated for the next 2-3 years. And if we, if we estimate the cover of the ocean that we could reach using autonomous vehicles with 1,000 kilometers range, and they are available right now, they are commercially available, the area that we could cover is very large. So if we are able to keep these robots persistently in the ocean in very remote places, and if we can keep the system collecting data in a continuous way, time-wise and space-wise, if possible, this is the challenge of K2D and how to do it. So the basic, the systems should be designed to be used in large scale, and there is a big example here in Portugal, the CamRing project. Basically, we'll try to use a new cable that is going to be deployed between continental Portugal, Madeira, and Azores as a new first smart cable example. We can replicate this example and break it in the most critical parts of the system. So basically, we have the nodes. We have nodes that are cabled, so included in the cable system. We have nodes that are autonomous, that are separated from the cable, and we have the cable itself. And autonomous vehicles can also be used to data and energy mule between the noded cables and the cables that are autonomous and separated. So this way we can extend the reach of the system, and this is one of the examples we are studying, a possible demonstrator in the north of Portugal, close to the area where we have an offshore wind exploration. So, guiding you very quickly through the project, what we have been doing, there are some parts that are very important to make it work. One of the most important is how we connect with the repeater. Therefore, we have been studying this node. We baptized it as node. This node has some essential functions that it has to guarantee. It has to connect with the repeater, and from the repeater it should take energy, and it should be able to transfer or interchange information, and it should also be able to carry additional sensors. Of course, we have spoken about temperature, salinity. There are essential variables that if we can collect in an extensive and continuous way, it's very important. And also to transfer power to the AUVs if we want to keep them there persistently, so they never come back to the surface. And then additional functions like localization, it's very important for autonomous vehicles underwater, using acoustics for long range and optical markers for short range, or for communications, basically to transfer information, long range, short bandwidth with acoustics, and short range for positioning and for more sensitive operations using optical or wireless. Of course, we also have to think about the AUVs themselves, how they should be redesigned in order to operate in these conditions. It's very important to design docking stations prepared for this type of environments. Also, adapt the ROVs or the AUVs to do persistent monitoring in the bottom of the ocean. And there are some tests ongoing, such as particular service conditions, like surveying or homing or docking that are particularly critical in this system. And these are some images of initial tests with short-range approaching or navigation. Then there is also the cable itself. The cables that we use are different, and they have some particularities. They are armored. They have the optical part, and they have the energy part. So we have to be able to translate optical signals into electrical signals and the opposite in order to, be able to tap in all types of sensors. So these are some examples of the initial prototypes we are producing. This cable was specifically designed for the project, and also some examples of the node. They are the first prototypes we are producing. And also the third part that is also very important, because acoustics is so important in this type of environment. What we see here is a simple draw of what could be the cam ring, the connection between continental Portugal, Azores, and Madeira. And this is the system we want to replicate in small pieces and critical parts. And we know that in terms of acoustics, we have different types of scenarios, either because we have different layers of density in the water, temperature, salinity. We have layers that reflect the sound. Propagation also changes. So it's very important to look at all these scenarios and be able to simulate them, model them before we have real operations there. So this is one part of the research, and the other part also to optimize the acoustic transducers that we have available nowadays, so that they could operate in these regions and at the same time be used for both functions that we have in mind. So both communications and passive monitoring, because passive acoustics is critical in these scenarios in order to extract variables about the environment, health of the environment, species, abundances, etc. So these are some examples of the simulations we can do. Basically, we have shallow waters, deep waters, and transition zones. All these matter, and we should be able to, basically control these environments in order to have a successful system. Finally, what can we do with such systems? Of course, this is more or less intuitive. We know that, you have an example here for monitoring of cetaceans. Cetaceans are sentinel species. We know that they have very long migration trajectories and patterns. If we are able to monitor these patterns, we are able to indirectly understand the health of the systems. If we detect changes in these migratory patterns, we are able to know that something is wrong. And exactly if we don't know exactly why, we can go after the answer for these questions. So there are several phenomena that we can start monitoring if we have such a system. Nowadays, monitoring like this is mostly restricted to coastal areas or opportunistic cruises, and they are very, well, they're very costly, first of all. Of course, if we can rely on cable systems to do this type of monitoring, this is a big change. Not only because we start having continuous data in time, so we can start creating baseline measurements and start comparing from these baseline measurements, but also to access the big picture, to look at regional phenomena at a global scale and the opposite, and to look at specific phenomena as basically proxies for the ocean characterization. We are also looking at use cases. There are several different use cases, but maybe even more important than to identify the most important use cases, I think we already discussed some of them today, is to understand that this is an unprecedented way to look at the oceans. If we are able to do it, most of the applications are still to be unveiled because we are not used to have such type of access to the ocean or information of the ocean. So we have very high expectations on what we can do if we can deploy something like this. To finalize, we already have some activities. These are some examples. I would like to thank the enthusiastic team that is involved in this project. This is a highly multidisciplinary project. The question, if we are really able to solve this and to deploy something like this, I think the answer is exactly in this type of projects. This is exactly the type of environment that allows companies to de-risk their participation. Basically, this is costly, time-wise and in terms of resources. It allows very large and multidisciplinary teams to meet around a specific challenge that is, well, almost a moonshot, and to form people, to bring PhD students, to bring people with new vision, with new, basically new forms of knowledge that are able to, after, go to the industry, after some time of well, knowledge gathering with us. And I would like to finalize saying that actually this is becoming a problem to us because we feel this. We feel that the industry is hiring PhDs. They are hiring people very much more aggressively than before, and this is a sign that things are working and they are working as they are supposed to. So thank you very much for your attention, and thank you for the colleagues and the partners of the project. Thank you.
Thank you so much, Eduardo. A very nice presentation. So now we have Ana Barros, and she will present us Operator Digital Transformation in Industry with a focus on the Operator 4.0.
Thank you very much. Thank you for the invitation to be here. I'm aware that I'm standing between you and your lunch, so I'll try to make it brief. So my name is Ana Barros. I'm from Fraunhofer, Portugal. ICO's a research center here in Portugal, an applied research center. Well, I had planned all this presentation, but I think that I will do something different. So listening to my colleagues here, what they have in common is that they are speaking about a vision of what the future could be, right? So there's a hunch, there's a vision, and the science contributes to that vision. And in this project, we all have a vision. I would like you all to come back to the human scale, which is the scale that we are working on in this project, Operator, looking at us as workers, and in particular, working at harsh working conditions in shop floors. So in this project, we all share this vision. I'm an industrial designer, so I will speak from a slightly different standpoint than other colleagues of mine from computer science or psychology in the project could speak. So when thinking about Industry 4.0, there is this very famous division or taxonomy related to the Operator 4.0 that talks about how technology enhances the operator of a super strength operator, virtual operator, and so forth. Now, if we think about developing the digitalization of industry with a focus on human beings, we understand that all human beings are different. All of us are different. And we are developing this technology together with people. And so we understood that we don't need to augment humans. What we need to do is to work on improving the workplace. So currently there are some technologies being developed to improve ergonomics in the workplace. There are technologies, many technologies focused on improving productivity, but virtually none on mental health. And this is the prevalence of mental health here in Portugal. Prevalence of mental health disorders, 23%. And this reflects a lot on, or this is a consequence in great part of working conditions. And so we want to tackle this as well. So thinking about not asking too much of operators, but really developing technology that is centered on human beings and on their experience of work and healthy experience of work, we are trying to do to improve the workplace. So a virtual workplace, an augmented workplace, a healthy workplace that lives up to the scale of humans. So in a nutshell, this project operator, we want to reconcile these metrics that are important for all stakeholders: productivity, ergonomics, and mental health. And we want to enable high quality data collection, but without interfering on the job. And these are data collection about human beings and their workplace. So in the end, if we can improve all these conditions, we can improve the way that we work, we can improve our health, and for companies, we can improve job quality and reduce absenteeism. So as I said, we have been developing all of this work together with the workers in the factories, involving them in the process, with the workers as our design partners. We have been working in a textile company, an automotive company. And this is what we've done so far. So we've developed the first device to enable self-report of subjective states in real time, so that we can get a metric of subjective well-being and mental health that we will then cross with ground truth from validated instruments in psychology. And people are able to see their own data and visualize their own data on a smartphone. And this has led to some epiphanies that people are using this and realizing, I didn't know, just looking at this data, I realized that I'm feeling pain at exactly the same time of the day, things like that. So they're getting to know themselves, and they can then act on their rights. This is how different operators use this device. We have published on this as well. We are also monitoring the environment. So we are monitoring thermal comfort, light, noise, and vibration at the same time by placing a sensor that we developed on workers' workstation. And we have developed our own inertial measurement units that people can use, so that we can track cycles of production, and we can use it in different places, and we can have setups that will evaluate then with the algorithms that we have developed ergonomic risk. So this is what we can do, this with a set of sensors that we put that are already at the same level of image capture, state-of-the-art systems, that we can, with these, we can help ergonomists to evaluate the risks of the workstations and evaluate how their interventions are improving or reducing the ergonomic risk. And together with Professor Elazar at the MIT, at the IMES, what we're doing now, the next step that wasn't foreseen in the project, but this, of course, is a collaboration of many disciplines. And Professor Elazar told us, well, maybe what could be interesting would be to analyze the optimal energy expenditure of the workers. If we have these kinds of measurements, then we can try to identify what would be the best movement that we can teach to people once they're learning an operation, so that they don't pick up bad habits and don't develop musculoskeletal injuries in the long term. So this is future work, and I've been submitting some proposals to work on this together. This is a very exciting work. And these are also, when we are collecting all of these data together, we try to make sense of all of these data, relating all these dimensions. That is something that was never done before. And importantly, giving these data back to the data owners, the workers themselves. So to answer to this, to the request that was made of me, I wanted to just bring you some notes about how this project has been contributing with critical mass, scientific outputs, tech transfer, and ideas for future research. So we have PhD students from biomedical engineering to psychology working together. We have 2 new PhD students selected for the MIT Portugal PhD grants. And we already have, with this collaboration with Professor Edelman, one of our students, PhD students, going for a research stay at the MIT precisely to explore these issues of energy efficiency. We have been publishing regularly and have ongoing submissions in high impact factor journals. And as I said, we have several follow-up proposals submitted, one already granted. And we have been seeing with the companies that this human-centered approach to development of technology has a lot of traction with companies. So people are understanding they don't have enough people, it's difficult for them to recruit, and they're understanding that if they invest in good working conditions, then they can retain people and also recruit more. So for future research, we understood that this project was an important testbed for pressing issues in technology ethics, privacy, and security. We're still dealing with many of these issues. We established many connections with EU projects that we want to explore even further. And we want to keep blurring the lines between the scientific fields, in this case of social sciences and engineering. Thank you very much.
Okay. Thank you, Anna. Very enlightening presentation. I will start with you, Anna. Sorry, so you were the last, so now you are the first. So you showed here that you are working with workers, but this is done in the scope of a research project. How do you think, and you said that now you are talking with companies that would like to implement this new solution in their own companies. How do you feel that their workers will consider this coming from their bosses? So the way they were going to implement, it's in a different scope, so the question is different. How do you think this will be implemented and used?
Yes, great question, thank you. So in the beginning, when we wrote the project proposal, we were thinking that the companies could be, these factories could be the takers of technology, but we really quickly understood that this couldn't be the case. This wasn't a viable business model. This is not their business. And so we started having interest, and we wrote a couple of proposals around that, European proposals. We started having interest from companies who do occupational health and safety services. And so they're very interested in they have a lot of demand from their clients to analyze mental health in connection with ergonomics, because there is a relationship, right? So musculoskeletal disorders lead to mental health issues and vice versa. And so what we're trying to pursue now is that idea of using this technology for these kinds of companies that do these sort of audits, okay? So, and then in this case, who has access to the data will be certified professionals or medical professionals or healthcare professionals, and who are not representing the company. So, and this we have discussed with the workers, and this, in their view, is a good way forward. Okay. I hope that I've answered the question.
Yes, thank you very much. So, Eduardo, how do you consider, so all of your projects are very multidisciplinary, very complex projects. How do you think that the results of your project can contribute to the technology advancement of the technology here in Portugal? So how can it be used maybe in different contexts or different fields?
Well, with me, thank you for the question. It's very difficult to answer this question. Basically, in the academy, we are very used to look at the problems and identify research opportunities or main societal problems that we need to solve, and we are not so much comfortable with identifying what's the next step, how the market the market uptake, basically. Well, with us happened the same thing. When we were putting the proposal together, we were thinking only about solving this main problem, about how to collect extensive time continuously and space, if possible, data from the ocean and from remote areas of oceans. And we got in touch with the industry. We realized that, well, there was some appetite, but not, well, it's difficult because it's risky. But on our way, we realized that the students that are participating, they are developing very differentiated profiles that make them prone to different job positions that didn't exist before. So I think this helps a lot to accelerate the change. The needs change while you do this because you raise awareness for certain issues. You're in contact with the industry, and the industry is very important to identify new opportunities. They are in the market. They know how the market behaves and how it changes. And because things change so fast nowadays, I think it's important to create all this huge diversity of profiles of PhD previous students and after professionals that can address completely new functions and in the companies, sometimes not exactly what they were developing during their research, but they basically developed a set of skills that would only happen in this project. And what we see is that it's very difficult to retain our students because they leave, they are hired, and we are very happy with this, although it's difficult for us because we have to find new ones. What we find is that on our way during the project, we find new opportunities, and we find that the consequences are not exactly the ones that we anticipated, but they are much better than what we thought before. Of course, sometimes we are more lucky, sometimes not so much, and the topics also influence if the topic is an emerging topic or not. But what we found is that this is the right context. If you have the companies on board, if you have the right project aims and goals, if you have the right team to discuss, what happens is unpredictable, evolutionary, and everything just merges into the goal. Actually, it's like science fiction movies. What you anticipate 20 years old happens because, well, you're raising awareness for these issues and you're creating opportunities just because you're implementing it and you're executing it.
Thank you,
I'm happy with it.
So, João.
Well, I would like to add something on top of what Eduardo just said. Couldn't agree more, but to add on top of that, you mentioned that at universities you address a research opportunity and you dig it around that. And for us in the industry, we take advantage, we go on board on this process because we want to create new products, increase our portfolio. And as an example, Eduardo was mentioning K2D, which we are also involved at Dstelecom. And the submarine cables is a very short industry on the sense that you don't have many players and very difficult to get inside this industry. And our opportunity as Dstelecom was, okay, we have to be smarter, so let's bring added value to the cables. Let's make the cables smart, so now we have a new product, and perhaps we cannot sell the cable in the future, but we can have a complement to that. And this is the kind of partnership that makes sense at the end of the day, because we can address, from the point of view of academia, the evolution in terms of science and research, and in terms of industry, the creation of new products and expand portfolios. And at the end of the day, even if the project is right now at low TRL, still far away from being commercially available, we are on the path towards that. And we find this partnership very fruitful.
Thank you. I will add another question, so you reply to Eduardo. So you have here two projects that you share. So we have academia, we have the industry. How do you manage in these consortiums the expectations that each part and interests that each part has, which are usually different? And because Eduardo just pointed out, and competing for the expert human resources that you create. So how do you manage this?
Is this for me or for Eduardo?
It's for you. Then if he wants, he can see it from his point of view.
Well, we see these partnerships as a way to evolve many aspects of the company. First, I would say human resources. So our teams have to cooperate with academic teams. Our goals sometimes are not exactly matching, but the process to get there, we have to do it together. And it's like opening for the teams when they, especially for the teams that were not used to work in such kind of environments, which is our specific case scenario, because as you can imagine, we come from the construction sector. And in the construction sector, at least in Portugal, we don't have that many high-skilled workers. So we need to adapt, we need to upskill, reskill, and the innovation projects, they help that. This R&D helps our teams to move forward, open to different perspectives, and have the willing to the evolution, to go on board of that. And at the end of the day, I believe that even though sometimes our objectives are slightly pointing in different directions, during the path to achieve it, most of the work is compatible and the goals are compatible.
Thank you. Eduardo, do you want to add something?
Because it's like a marriage. It doesn't go always well, and most of the times it's difficult. So every time, or everyone that has projects with the companies knows that it's sometimes difficult to bear with the impatience, because it's difficult to understand why things take time sometimes, because we are not working with fully defined schedules, and there is a lot of uncertainty, and sometimes it's difficult because there is some impatience, and it's understandable. But I think academia is absolutely in need of this, because we need to be in contact with this reality. We need to understand that, and if we don't, even if we don't feel it, we change the way we do things, because we need to be exposed to this type of, between commas, pressure, because in the end, what we should do is to serve the society. We should do things that go and meet the needs of the society. And if we can learn how to do things in a way that we can address the needs of the society slightly better, I think we can do it. And the best way is to be pushed by the companies, because they have certain schedules, they are used to meet the deadlines and control very well the risk. Well, we are in the opposite. We are undisciplined, we don't like rules, we like to be free of mind, and sometimes, this is just to meet halfway, right? Like in a marriage, we have to, and this is very, there's nothing better than this, I think, for both.
It looked like a little bit that you were saying the man is the one that that has no rules, it's free of spirit, and the woman is the impatient one.
So I'm the woman then?
I don't know.
Okay. I just wanted to say, to compliment that, since you are making the parallelism with a marriage, at the end, love always wins. So the product always get to a...
You are certainly more diplomatic.
So, Paulo, you raised a very big standard here with the Green Island project. It's clearly a successful flagship project for the MIT Portugal program. It clearly has brought a very big impact in human resources development, how they are now in leading positions in our industry, in our government, in positions that they can now decide what is going to be done. So what big advices do you have for these projects and the projects to come so that they can be as successful as the Green Island project?
Well, I think the success, as it is, I'm not going to the marriage business, so because my marriage suggestion is 3 people. So that's why I don't want to enter in that situation. So I think it is important to bring together academia, the companies, and eventually the governance, the government or whatever. So, because this is of course very important, and we cannot work without these 3 dimensions. So there is the regulation. All of us understand how it is important nowadays, for example, in the energy sector, and that's crucial. And for example, what we did, all the models of the smart grids, of the energy system, what they did was to create trust in the government of the Azores that they can take the risk. I want to make something clear. Smart, sustainable energy system in an island is super difficult because, of course, for example, consider Portugal. We have a lot of renewable energies. We have a record worldwide for many days. We lived only on renewable, 100%, a few days in a row. But of course, when we have excess, we can export to Spain. So there is in an island you cannot put it anywhere. So it's more restrictive, so it's more complicated. So the government needs to be trustful, the company needs to be trustful, and then you need to have companies that invest, and of course you need to educate the people. Above all, this is about skills. And what I see, as of course it has been discussed here, what I see which is very interesting is that from those initial moments, so the Green Island, we are speaking between 2007 and 2013, so things have evolved, even with the people we work at MIT. So let me tell a joke. So when I started working with MIT, I had all these full professors and so on, and one full professor, which I respect a lot, was, I think he was my friend. He told me, you look, where are the running horses? And I never forgot that. We need the running horses. So the guys that are, I think this is MIT language, I learned about this. So this is a guy which wants to progress and will do work, and which is effective. And of course, we need those people everywhere. So so everybody needs to be rowing and be pushing forward. And I think the MIT Portugal program had the opportunity, and I think the intelligence, I don't know, and was lucky to evolve in that way. So now we have different people in different areas which are pushing in different directions. So just to give you an example. So by the time we, for example, we look at urban systems, house by house, and so on. So now we are lucky to work with Christoph, for example, and then we model the full city. And this is, of course, super important when we look to the energy communities and to address the new problems that we face. But of course, now we are in close contact, for example, with the Secretary of State for Energy Management. We are still working and have people that went to GALP, to EDP, to DST. We have projects with DST, as it was very clear here. So I think this is the big secret. So to of course, train people, to empower people, and then as much as we can, because this is the beauty of Portugal. It's a small country, so we all more or less knew each other. So to get together the government, the people, the universities, and the companies.
Thank you, Paul. Clearly, this third party
I don't go to the
critical.
marriage things. Very difficult.
So I would like to give the opportunity to the remaining participants. I don't know if this brought you any questions that maybe you want to ask to any of them. You were so enlightening, so no one has any questions? No?
Or comments.
Or comments? Nothing. Oh, okay, John, thank you. You moved.
That's why he's a handsome man.
So actually, I have 2 questions. First, for Paulo, the modeling that you guys did in the Azores, right? To what extent did you propagate that modeling into the main Portugal itself, and did that come in through EDP or things like that? I presume there was a flow of that. So let me give that question, and I have another one for Eduardo.
Well, that's very easy. So we work very, very close with the government. For example, just last year we finished the work for a project based on all the knowledge that we developed in the MIT Portugal program, which was ordered by the Ministry of Energy, well, in Portugal is economy, energy, which was the future of storage in Portugal, for example. And this is one of the documents that the government is now adopting for future strategies. So all the time. So that we are very fortunate to have this relationship, which has been working in a very nice way.
And Eduardo, this is stimulated by the question that Doug asked to Brent, right? Which is Brent's missing measurement that he wants is the salinity and temperature of the underwelling water in the Antarctic. So what's the feasibility of putting a cable into the Antarctic? Okay, and what would be the challenges and feasibility to sort of propagate the idea to actually support the measurement he wanted?
Thank you for the question. Maybe.
No, it's you too. Go ahead.
Thank you for the question. Well, when we look at the system as a whole, there are other challenges. And the main challenges happen when we want to create the global system. Cabled, sensorized systems, local, they exist. There are some examples, and I think it's possible to do it in Antarctica, just taking examples from other places in the world, maybe in Japan. The SMART concept is based on a set of basically 3 sensors, the ones that I think are most important for oceanic main currents, right? Temperature, salinity, and in this case, pressure or acceleration. So basically, if you can measure pressure, you can measure salinity and temperature, you can capture most of the largest phenomena that affect Antarctica. And I think it's possible and it's feasible. And it's maybe the case where you have the least technological challenges. Maybe I can add and take the question to look at the problem in another way. And what we saw and what we felt is that there is a big bottleneck. The industry is very cautious about taking action in, well, basically adopting this type of strategy, because when we look at the oceans in a global perspective, we can be looking at sensitive information, and sensitive information can hinder approaches that allow us to collect massively information. So the main players in the market that João already mentioned, the main restraint for them is they are used to do, and they're very good at doing what they do now. It's telecommunications, it's over. If they start collecting information that may be faced as sensitive information, there may be difficulties, so they may be not so free to actuate in any place of the world. So basically this is a difficulty, this is a bottleneck, and at the same time it can be an opportunity for companies that want to be game changers. So basically we don't have anything to lose if we start with a completely new approach, and if we start collecting what, basically it happens already with satellites, but we are already used to it, everything is visible. Under the water, we cannot listen to everything, so, but it's going to happen because we need to have access to this information. And maybe this is also an opportunity because classical players, there is a big resistance because there is a big risk. It's a change. So summarizing, I think it's a very good application, possible application, Antarctica, because actually there are some cable systems already in place in the north, I think, and not in the south, to look at the currents and how they change, to create this baseline information and monitor it real time, constantly. There are also big data problems, how to manage all this information, but this is another issue. But at the same time, well, when we look at the global perspective, if we create actually the conditions to do it and to deploy it, there may be some opportunities for game changes because classical players see some difficulties there. So basically, this is my feeling or my experience from the last 2 years. Thank you.
Doug.
Sorry, Paulo, I'm not so handsome, but but I have a big heart. By the way, Paulo, I greatly appreciate your background in the history of the MPP program and how it's evolved, because you have a unique perspective on this. And I wish we could go back in time and show how far it's evolved, because it's stunning when you see the beginning compared to now. But it's very hard to pick that up from just a snapshot in one meeting. So I really appreciated that you went back that. To get back to John's question on this, I was in Antarctica just recently. I was on a ship offshore, a research ship. And Australia is putting in a cable into Antarctica. And they're doing it because they need power. And then when they looked at the cost, they went, oh my God, you know, this is beyond what we can do. And then they said, but we need the data, and we could put in a smart cable. And so it's exactly to your question, it's people have realized that this is what they need. So this is playing into it. There's only one other country that has a smart cable right now, and that's Japan. They put in the first smart cable. It's not so smart. But it was for tsunami detection, and Portugal is putting in the CAM system, which will be the most sophisticated cable ever, and by far the longest. So Portugal's a leader in this, so it's impressive.
That's impressive.
Congratulations.
Portugal.
Thank you very much, Doug. Do we have, please, thank you.
Well, thank you. It was wonderful watching all the presentations, and I think my question is going to Anna. And Alexandra opened already the floor to this kind of questions related to the reactions and interactions with the workers. So I have two small questions. First, do you have any kind of defined sample, or it was a kind of random sample of workers in terms of gender, age, whatever, and fields of work and so forth? And the second is, you talked about the presence of several experts from bioengineering, psychologists. Are you talking about multidisciplinary or interdisciplinary? We go again for the difficulty of the languages and the communication between the different experts and scientists. Thank you.
Okay. Thank you very much for the questions. So we tried two approaches. So for the what we call the participatory design, so involving the workers in the design process, we couldn't have all the workforce in all the companies, of course, because there are hundreds. And so what we tried to do was to ask and recruit people with different, we couldn't get so much difference in gender, so we have one company that's in the textile industry, so they're just women working, and then we have a company in the automotive industry, they're almost just men. So we got the balance there, and then we tried to balance age and years of experience in the job. And then we also tried to have people participate who would have these different levels of experience, but were doing the same operation. Okay, and so these were the people involved throughout the whole process, designing together with us. These are the people we interviewed and observed. And they were also the first people we collected data from to compare the different kinds of movements depending on experience. And we found we had very interesting insights about that, about the flow of movements as people get more experience. And then the School of Psychology, the people in the project, they are specialized in work psychology. And what they did was they developed a specific questionnaire, an instrument for this project, that with which they are collecting data across the large samples in the representative samples in both companies. So this is the approach that we took. I hope that it answered your question. And the second thing was about it being inter or multidisciplinary. Well, I think that when we go off to such a venture, joint venture together, we always aim for more. We always dream higher, right? We dream of more interdisciplinarity. What what we see that ends up doing, not just in this project, but in other projects that we mix disciplines, is that sometimes we have, within a subset, we have two disciplines that really can find common ground and work better together, and sometimes that spreads to the whole consortium, sometimes not so much. In this case, I think that we have been working together quite a lot. We have been publishing together. Actually, this is one of our problems, so that where to publish, because we're we're mixing subjects. And so on that point, I'm very happy with the results, and I think it's multidisciplinary.
Okay, so I would say that to finalize here, I would take two things from all that was said here. So for big success, clearly we have to bring politicians or the people that make laws and create laws here into these consortiums so that they can get, or at least involved in the discussion, so that we can make them sensible and trust what is being made here, so that they can define new laws. And second thing, it is very important to form the new resources, human resources, so because projects have limited time span, and clearly it's the resources that we create here with these ideas in mind and that can see the future that will be able to enforce this in the decade. So here, Paulo was telling us of the project that was 15 years ago, and how these people are all now in leading positions and are able to guarantee that the idea keeps on going. I would like to thank you all, this amazing panel of four with four amazing also projects. Thank you all for participating. We will now have lunch. So see you in a bit.
Thank you, moderator.